Welcome to Land a House. I'm Seth. In this video, I'm installing a transfer switch. This will let me turn off grid power and use a power station powered by a solar panel to power my shop whenever the grid goes down. This is video 2 in a 3-part series with Project Solar. Project Solar is a company that has been selling and installing affordable solar panels for a very long time, and now they are diving into power stations. So if you missed the first video in this series on the Project Solar 2000 watt power station, I'll have a link to that down below. All right, let's go ahead and start installing this transfer switch into my breaker box here in the workshop. Before I begin installing this, let's talk about what a transfer switch is and how it works. So a transfer switch is a box that accepts 2 inputs and allows you to swap between those 2 inputs to feed one output. So if I open up this top lid here, you can see there are switches up here, and these will let me go between generator, off, or line. So the line is going to be your typical grid power or main power. So if these switches were down here, then these down here would be bypassed, and this would just allow all those circuits to be run from normal grid power. You can turn them off by going to the middle switch, or let's say the main power is out or grid down, you can click up here to the generator, or in my case, a power station, and that will allow these breakers to then take action and feed my circuit. So that's basically what is happening here with this transfer switch. Let's go over this real quick and I'll show you how it's wired up. This particular transfer switch has the option to mount from the outside of a wall, or you can put this inside of a wall. So if I open up the lid here, you can see this one has 4 different sets of switches and 4 different breakers, all at 15 amp. Down here, I'm going to be opening this up, and I can place this adapter here, which will let an extension cord plug up to the unit and power this through a power station. So down here on the bottom is where the wire harness comes out. There are 4 sets of red, 4 sets of black, a single green, and a single white. So I'll be discussing those here in just a bit. All right, let me go ahead and discuss how this thing works real quick. For the sake of simplicity, I'm going to use a single breaker to represent this system here, but of course in your house panel you're going to have lots of them. This is representing the main panel of the house. You've got your grid coming in up here, 1 and 2, neutral bus bar, ground bus bar, and then over here is where all of your breakers are clicked into. So typically in this system, when the power comes in, it goes to a breaker. The black wire is going to be the load. It will go into the breaker, and that will go up to the load, such as this light here. It's got a black and a white wire. And from there, the white wire comes out of the load and goes to the neutral bus bar. So it just makes a loop around and it's done. But whenever you're installing a transfer switch, it's going to be a little bit different. So if you notice in here, there are 4 circuits. The power is going to go up here to these switches first. So what happens is you take your load wire out from this breaker, and you're going to attach it to one of these. So this black wire, let's say it goes to A right here. You're going to take something like a wire nut, or what I'm going to be using is a Wago connector, which is one of these, just clamps down on the wire, and it's a straight line instead of having a wire nut. So your load's going to here, which goes up to the switch. And that switch is going to determine, do I send the power to this breaker or to that breaker? Which means we have to connect this breaker. So the corresponding red wire to that one is now going to go over to this. So when the power is coming into either this spot right here or to the main grid, you can say line, which means go from here, red wire, up to here, and then out to the light. Or generator, which means go from this plug here up to the switch and out to this one. Hope that makes sense. So basically, whatever 4 black wires we want to take from this one, we're going to go straight through here and connect to these black wires here, and then the corresponding, which these have, let's see, should have an indicator on here. Yep, so this is the B wire. This one over here is the the A wire, and so they'll have matching. Now your white wire in the transfer switch needs to go over to the main panel neutral, and the green wire from the transfer switch needs to go over to the main panel ground. So, all right, that's the basics of getting one of these transfer switches wired up. Let's go ahead and go over here to the main panel and get it wired in. This is the main panel coming into my workshop, and I have a knockout up here that I'm going to use. Now the 1-inch metal conduit that was shipped with this transfer switch is not very long, so I also have to have it up pretty high, but the cord I'm going to use is plenty long enough. So what I'm going to do is drill out this spot right here, and that will allow this metal conduit to go in and get the wiring into my box here. So I'm just going to use a 1.25 inch bit and get this right here drilled out. There we go. I may route out a little bit over here as well to allow this to have a bit of a turn to it, because this right here needs to get in there, and then this right here has to be against the wall. So now before I hang the transfer switch up on the wall, there's a few things that have to be done. The first thing is I have to get all of these wires here through this conduit. Now it does have a plastic protector in here to help with this, but it may be a bit of a squeeze to get all of these in here. Let's see what we can do. All right, I'm just going to feed all of these through to the other side. The plastic connector, yeah, might come loose here, but we can stick it back in there in just a moment. All right. Now in this kit, it comes with a metal bracket that allows you to tighten down onto this right here so that the wires will be at a 90 degree from the box. And so you just get those in here, and then I'm going to be using this to lock this down. I just realized that this transfer switch kit came with both the straight on end of the conduit here or another one of these 90s. And so I want to use this 90 to get into my main box there. And so I actually extended the hole size a bit so that we could use this. So let's go ahead and get these wires through this other side here. And this will make it a nice clean pass through into my main box. And then just like with over here, I'm going to get this piece cinched down, and that will help it to make a good 90 degree turn in here. This to be, let's see, if that's up like that, this one will be, yep, about right there. Now that I have the wires going through this metal conduit, it's time to work on the inside of this box. So let's go ahead and open this up. And I've already taken the 2 screws out of here so we can open up this panel, but I also need to remove the front cover here for our adapter to go into. All right. So this kit came with this plug adapter here, which will go right down in this place. And let me show you how this is going to be wired up. So if we remove this panel, we can access the inside here. Now, this transfer box could use 2 different leads coming in, so we would alternate these breakers. But with the way this is designed, it's only supposed to take 1 input, which means it's got this connector here, which will take both sides of this and make both of these 120, basically, instead of having the option for 240. So what I want to do is take this right here and go through the box like that right there. It's important to do that first, or else you'll have to back this step out. Now that I have that done, I can take both the red and black and match them up in here. It does not matter either side. You just press firm and that will make the connection in there. Go over here to the red one. Same deal, just press this into the other side there. All right. And those all lock in through friction. Very good. And now there is a green wire here, and that's going to go to the green screw right down here, and then there is the neutral. So essentially, this plug and the grid main will both be on the same neutral, and the ground will also be on the same ground as the main panel. So I need to be able to turn this up here, get these wires tucked out of the way, and then this white wire is going to have to go into the back of the plug right over here. It may be a little difficult for you to see, but let me get this screwdriver here. And I'll loosen this up. It's pretty loose already, so. All right, so I got to find a way to get this white wire over in here. And so yeah, it may be out of your way for being able to see it here. Okay, once I have that wire in, I'm just going to tighten it up really good with this screwdriver. Very good. And then lastly, like I said, the green wire here needs to connect over here to the green or the ground terminal. And it does have space in there for 2 wires to reach. I will show you these connections up a little closer here in just a moment, once I get these all done. To recap, I stuck this plug through the metal, and then I took the ground and put it into the other grounding screw right there. So those 2 are now linked up to the box. I then took both the red and black wires that are connected down here to the breakers, and I put those into the switch as well. So those are now connected. And then lastly, I have the white wire is connected to the other side of the switch here. And so all of those are now linked up together. I can put all this back in the box now, because what we're going to be using next is going to be everything coming out of this conduit here. The space that I'm working in is a little bit cramped, so I'm going to do my best to get you to see what's going on. So first, before I stick my wire in here, I want to remove this nut off the other end of this conduit here. Otherwise, you'll have to take it all back out again. Now I'm going to take my wire bundle here and stick this into my panel. Now, keep in mind that it's best to work on a panel like this with the power turned off. I've got the power on so you can see what's going on here. Otherwise, my lights would be out, but just keep that in mind, that it's best to turn off the power. Now, obviously, I have lots of extra wire over here, so I will have to most likely cut some of that down, but just get this conduit started in here. Okay. Well, that was awkward. All right. Whew, okay. There we go. I will come back in a moment and get that locked down better, but at least it's enough to get it to stay. And now the fun begins. So I've got a long length of wire here that I need to cut down. First, I need to make sure I use my little nut to go back up and lock down that conduit into place. So let's go ahead and do that before I start working with these wires. With these wires, we need to do a few things. Like I said before, the black wires, there's 4 of them. They will be connected into the wires that are currently going into these breakers. Now, as you can see, I have a bunch of breakers here. I want to use 1, 2, 4, and 7 into my transfer switch up here. So what I'm going to do is take out those, and then I'm going to use those Wago connectors to go from this wire to those black wires from the breakers. And then, after those are connected going up there, I will then take the red wires with the corresponding letter on them and plug up into those breakers. And then the green wire is going to go over here to the ground bus bar, and the white wire is going to go over here to the neutral bus bar, and we will be all set. So, because some of these are my lights, it may get a bit darker in here as I'm working, but I will try to do this so you can see what's going on. So first of all, let's start with the neutral wire. I'm going to have to go down here on the lower side, so I'm going to cut about right here to give myself a little extra space, but also cut out some of this excess wire here. Now the green wire is the ground. It needs to go over here to this side. And so I'm going to give myself even more and cut about right here to make sure I have plenty of wire to get down on that side. And now for these red and black. Now the black has lots of extra wire going around over here that I can incorporate. So I'm going to just cut these all off at about this length right here. And of course I can kind of tuck them out of the way if I need to, but this right here should be fine. With the red, they have to be able to curve into these breakers here. So I'm going to do about right here, and that should give us a little extra to work with. All right, each of these needs to be stripped down. So I'm going to take my pair of strippers here and get each one of these wires stripped down. Okay, it was almost impossible to film to show you the connection of the ground wire over here and the neutral wire back there on the back bus bar. So I just got those installed and we're gonna leave them be. So like I said, I want to do 1, 2, 4, and 7. And so this one right here is my back lights, which they're already off up top here. So I'm gonna turn it off by the breaker, and then I can use a screwdriver to unscrew that one. I'm just going to pull that wire out. All right, and so now I'm going to dedicate circuit A right here. So if I look on my wire, it's got a bunch of A's lining all the way up here. All right, now I can use this Wago connector to connect this wire to this wire here. Should be pretty simple. I just stick this end right in here, lock it down like that, open up this side, stick this one in, and lock that down. And now it's made a good solid connection in there, and that can just be tucked up wherever I need to tuck it here. All right, and now I need to find the corresponding A here on my red wires. Let's see which one we got here. That's B. There we go. There's A right there. So this now needs to go back into the breaker from this side to feed that circuit whenever it is on the grid. I think it's just going to be easier to pull this loose here and get it attached. All right, very good. Okay, that's what it's going to be like for the rest of these. I need to do 2, 4, and 7, and I'll have all of my lights and receptacles here in my studio, and I'll be good to go. Now, if you mess up like I did, and you cut the letters off of your black wires, and you don't know which one is C, B, A, D, whatever, you can use the continuity setting on your multimeter, which means if they touch, it's going to make a beep. And so I've opened up my circuits up here to be on the main power, and I've turned on the 2 breakers that I don't know the letters of. And so if I reach over here and grab a red wire, this one says it's D. And so if I hold here and touch here, all right, that one right there is the D wire, because if I touch this one, nothing. So this one right here is D, which means this one over here must be the C. Yep. All right, so that's the next one I'm going to use is up there. And that's just one way you can determine the continuity of those wires. I just finished getting the wiring done. Let's take a recap of what's going on. So previously, grid power would come in from here, feed the circuits, and then a black wire would come out of a breaker going to the loads, and that was it. But now we have the option for 2 inputs. One can go in right here, or one can go in from right here. So if it's on grid power, which means the line down here, the breakers are all towards that, it doesn't matter if these are on or off, they won't be accessed. So basically it's saying grid power comes in through the red wire, goes up here, recognizes that the switch is turned to grid, goes right back out to the black wire, off to the load. But if you've got a generator or a power station going to this, and you've got this turned up to the generator setting, then these breakers no longer mean anything. And so the power is going in from here, hitting the switch and then going to the breaker here and then going out to the loads. I hope that makes sense. It's less complicated once you actually start getting into it. Let's test this out and see how well it works with the power station. I just moved the Project Solar power station down here to the corner. Let's go ahead and turn on the AC. Hold that down. All right, get things turned on here. And now I can take this plug and get it plugged up over here. Okay, plug that up. Take the other end of my cord and plug it up into the transfer switch. Seems to make a nice solid connection and should not be falling out of there. Now let's pretend that the power has gone out for circuit A. So you can now see that my can lights are out over here on this side right here. And so now if I turn this to off and then turn it up to generator, the lights now come back on, which means the power station is now running those lights off grid. I can move down here. Looks like those are consuming right at 50 watts. Very cool. Now, let's say that my other set of can lights are now out. You can see those have gone down. So now let's take circuit number B, flip that up, and now we have them back on again. Now these overhead lights use a lot of power. Let's see what we're working with here. 307 watts to run those. Now it'll run that for 5.4 hours off grid, which is very nice to know. So if I am working down here for a while and the power's out, I'll still have that going. Now one thing I want to try is to turn off my other system here. So that one and that one. Turn these on. Okay, had a little flicker there. Now that is running my outlets on this side of my building, but it's also running my saw. So let's see if my chop saw will run off grid. All right, off grid chop saw, cutting through a piece of 4-inch pipe. Let's see what happens. All right, I'm gonna say that that was too much of an initial surge power to keep that going. Okay, it's a no-go on that giant chop saw. There was an overload. But as far as lights go, I'll be able to use this power station no problem. And I imagine I can also turn on my TV while I'm out here as well. Let's see how that does. Yep, TV has come on. Looks like the internet has not caught up yet. All right, there we go. Internet's working as well. So let's see with the TV on. That's my standard power consumption right there. Got 305 watts. Now I don't often use these can lights over here. Let's see, so about 250 watts, 6 hours from a full charge. Very cool. Yep, I could definitely run off grid with that for a long time. And there we go. That's what it's like to use the Project Solar 2000 watt power station to run my shop lights and outlets off grid. So currently, as you can see, I'm running off of the generator up here, which means the power station is what's supplying power to my lights. So if I were to go in here and turn off my lights, it would not make any difference. Very cool. Now, the application that you would use this for is most likely in your home. So you would install this box nice and pretty next to your main panel and have the circuits that you want to run hooked up to the transfer switch so that the Project Solar could run that in an emergency situation. So for instance, this 240 watts worth of lights, which if you look up here is lots of lights. I've got all those over there on as well. So that right there could power your lights for, looks like 6.5 hours on this power station. And that's how I install a transfer switch to use a portable power station or a generator to run part of my circuits off grid for the house. Please check out the links in the description down below to the Project Solar PowerBank 2000 power station. And be sure to stay tuned for the third part of this series, where I will have a review of the Qcell 400 watt solar panel that will be charging this up during the day so that I can keep my shop going at a grid down situation. I'm Seth with Land to House, and I will see you in the next video. Bye.